In this video, I'm going to show you how to handle exercise like number 4 on page 4 in your lab handout. So this one is very similar to that. So I'll show you this. So hopefully you can do the one on your lab handout. Okay, so in this particular example, the period as a function of length, the data is here, and the equation is also there, which is given by 2 is 2 pi square root of L over G. So we need to use that. Of course, the period T and the L are the variables, and G is a constant. Of course, 2 pi is also a constant. All right, so first thing you're going to do is to make the graph. All right, so you know how to do that. So if you highlight the data and make the graph, you're going to get a graph like that. This is, of course, T versus L. And then you have to do a trend line. And we need to do a power trend line in this case. So if you do the power trend line, you're going to get something like this. So you see that the Excel is going to give you this equation. It's always given you in X and L, sorry, X and Y, but we need to make sure that we write it in our variables. So if I write this in our variable, what we have is actually the Y is our T. So if I write that here, so T is equal to 2.002, and X is the L we use, so L, and raised to the power 0.5041. All right. Okay. So one thing we need to pay attention is, Excel is going to give you all the digits, but we had to use whatever appropriate digits we have anyway. So, and you will see that in a minute when I show you this. So this would we get from the fit. Now, if we go to the equation we have, if I rewrite this a little bit, so this is basically T is equal to, I'm going to combine the root G with the 2 pi. So 2 pi divided by square root of G, and then I'm going to put the square root of L. So I haven't really changed much. Okay. And then you should also know that square root means to the power of half, which is 0.5. Okay. So if I rewrite this, T is equal to 2 pi over root G L to the 0.5. Okay. Because square root means the same as the power of 1/2, which is 0.5. Okay. So now if you look at this, with this one we have here, which is basically, okay, let me rewrite underneath. If I write this, T equals 2.002, I do have L to the power 0.5, and then I have 0, and then I have a number 41, but I can ignore that. All right, so if I drop the 0.41, I will left with just 0.50, which is very similar to what you have right there. Okay, so these are very similar now, and the T is also very similar on this side. So then basically we can use the coefficient. By the way, the 2.002 you see here on the fit is known as the coefficient of the power fit. Okay, so that is the coefficient of the power fit. All right, so this is going to be the coefficient of the power fit. Okay. All right, so but that is also same as, so if I take that number, which is basically same as this one right there, so all I had to do is I could say that 2 pi over root G is equal to the coefficient of the power fit, which is 2.002 in this case. So now you can solve for G here, and then you can find out how much is G. All right, so the way you will do this is, of course, since the G is sitting inside the square root sign, you may want to square both sides. So if you square it, it'll be 4 pi squared over G, and you square this number, which will be almost 2 anyway, so I just square it to 4 there. So now you can solve for G anyway. All right, so, and then you can also cancel the 4 if you like, or you can solve for it, doesn't matter. So G will be, so you can move the G there, 4 down there, and then you can solve for it anyway. So that way you can figure out how much is the G there. Okay, so you'll figure out how much is G. So it's basically 4 pi squared over 4, and you should get something very close to 9.8. That's what you, anyway. So that's the way you get the G in this particular example here, using the coefficient of the power fit. All right, next I'm going to show you